Welcome all to our video lecture series on textile effluent treatments. In this video, you'll be seeing about the second unit, which goes around the characteristics and treatment of cotton, wool, and synthetic textile processing effluents. And then we'll go through the primary treatment methods for treating these effluents. In our previous lecture series, we saw about Unit 1, where we covered about the various discharge standards for disposing of these effluents, various process included in manufacturing of the textiles. So let's go to our topic. So as we have already seen in the previous series, where we saw about various wet processing techniques. Here similar, the same, here you'll see about cotton in this video. So basically, in textile manufacturing, first the source material is chosen. Here a cotton is chosen, then it is undergone through various processes, and it is converted into yarn. Yarn is converted into sized yarn, which is then weaved to form a cloth, a fabric cloth, which undergoes wet processing treatments, and it is dyed, printed, and it is performed as a good, and then it is transferred to sales. So overall process which involved in a cotton textile manufacture, we will see in the coming slides. So the waste that is coming out from a textile industry is of two types. One is the process chemicals and the other one is fiber waste. Process chemical is mostly aqueous in state and it contributes to the water pollution. So we will be concentrating on it. The fiber waste or solid waste, and it's managed by solid waste management. So these process chemicals contributes to our water pollution. So hence we need to treat this process chemicals which is coming out in the effluent. So the nature of the waste is affected by the following factors. First one is type of the textile facility. Second one is process and technologies. Third one, types of fibers and chemicals. Types of textile facility refers to whether it is a cotton textile mill or a wool processing factory or a synthetic textile manufacturing factory. So based on that, the nature of the waste which you obtain varies, and the process which is adopted varies with each fiber chosen, and the technologies adopted also varies with the fiber chosen, and so it also depends on the textile facility. And next is types of fibers and chemicals. So all these contributes to the effluent which comes out from an industry and its nature. So as we have already seen in a cotton wet processing, first the fiber is chosen, then it is sorted out, then it is cleaned, and then it is made into a yarn. The yarn which produced is further processed by wet processing. First it is sized using sizing agents, then it is heated, or the fabric is rolled fastly, and the series of burners are used to burn the extra projection. Then it is the sizing components are removed by desizing. Then again the cloth is cured. Cured is nothing but a process of scouring with alkali agent, and next bleaching is done to remove the natural color of the material. After bleaching is done, the material is mercerized in caustic soda solution, so in order to give a stabilized feature or a strength to the fabric. After mercerizing, dyeing is done. Mercerizing is characteristic to cotton industry. Only in cotton mercerizing is done. Then we go for dyeing. After dyeing, finishing is done, and then printing is done. So in all these methods uses water, so it contributes to the effluent. So whatever the chemicals used in each of the process, we obtain it in the effluent, and all the spent fluids were also obtained in the effluent. So here cotton textile industry uses water, right? So the in each process how much quantity of water is consumed and overall rough estimation is obtained. So in sizing process about 500 to 8,200 liters of water is used per 1000 kilogram of product. Similarly, in desizing, 2500 to 21,000 liters of water per 1000 kilogram of product is consumed. For scouring, so 20,000 to 45,000 liters of water per 1000 kilogram of cotton product is consumed. Similarly, for bleaching, it ranges from 2,500 to 25,000. For mercerizing, 17,000 to 32,000. For dyeing, it varies from 10,000 to 3 lakhs. For printing, it varies from 800 to 16,000. Sorry, 8,000 to 16,000. So this is the water requirement for a cotton processing. Next, we will see about characteristics of cotton processing effluent. So the effluent which comes after the processing of cotton in each process contains various parameters. So some parameters which we take into consideration are pH, specific effluent volume, biological oxygen demand, chemical oxygen demand, total suspended solids, total dissolved solid, oil and gas. We will be taking into account all these parameters. So first the process is desizing, where we use water. So in desizing, the sizing material removed, mostly you will use starch as sizing material. So enzyme starch is obtained in the effluent. The pH is around 6 to 8 and the effluent volume is about 2.5 to 9 liter per kilogram. The BOD of the enzyme starch is about 45.5 kilogram per 1000 kilogram of cotton, and COD is 91. The total suspended solid is about 89. Total dissolved solid is about 5 kilogram per 1000 kg cotton, and oil is obtained. Oil, that is natural oil removed, is 5%. 5 kilogram per 1000 kilogram. And similarly, in case if polyvinyl alcohol is used, it's also removed, right? Other than starch, we can use polyvinyl alcohol, carboxymethyl cellulose as sizing agents. So those agents were removed in desizing. So the pH is around the same, but the BOD and COD varies. The BOD is high in case of starch. Next, in scouring, we wash it in a caustic solution so as to remove the natural oil and the unwanted impurities in it. So here unmercerized greased fabric, the pH is around 12.5. It's alkaline since it is washed in a alkaline solution. So the pH is alkaline in nature, and the specific effluent volume is about 2.5 to 43 liters per kilogram. And in so BOD is around 21.5 for unmercerized greased fabric and 16.5 for mercerized greased fabric. And so as the other parameters also vary, and it is high in the case of unmercerized greased fabric. So for mercerizing, the pH is around 12, and the effluent produced is about 231 to 306 liters per kilogram. So it contributes to the large volume about the overall process. In all the overall process, the mercerizing contributes to the large amount of volume of water effluent obtained. And next comes the bleaching. Bleaching operation, we use hydrogen peroxide or sodium hypochlorite bleaching agents. So it is obtained in the effluent. And in dyeing, we use reactive dyes for natural fibers. Since cotton is natural fibers, we use reactive dyes and it is obtained in the effluent. some basic dyes, direct dyes, wire dyes, sulfur dyes may also be used. If used, it is also obtained as effluent after the process. So in reactive dyes, the pH is alkaline. Basic dyes, it is about 6 to 7.5, and you can see in the table sulfur dyes have 8 to 10 pH. So these are the effluent characteristics for a cotton processing effluent. So the cotton processing effluent, overall it is highly alkaline, and we can't allow this effluent as it is, or we cannot treat uh, if the effluent is highly alkaline, we cannot treat this effluent using secondary biological treatment methods, as the bacteria or microorganisms highly sensitive to pH. So the pH should be maintained up to, between 7 to 9. So we need to remove this alkaline nature. So we need to do neutralization surely in the case of cotton effluent, as it is highly alkaline. So general, we can see it is in a tabulation form. So fiber preparation produces little or no wastewater. It is a dry process. Yarn spinning is also a dry process, so we won't receive any wastewater generation. So slashing or sizing produces BOD, COD, metals, cleaning waste, and sizing materials as effluent. Weaving, knitting, tufting produces no wastewater. And desizing produces the sizing elements will be removed, and there will be lubricants, BOD, synthetic sizing compounds, antistatic compounds will be removed, so it will be present in our wastewater. Scouring removes the natural oil agents present in the fiber, wax agents. So other than that, we will use some disinfectant and insecticide. If oil culturing, insecticides will be used, so such compounds will also be removed during scouring. In addition to that, we use alkaline agents, so NaOH or detergent soaps will be also will be present in the effluent wastewater. Bleaching, surely hydrogen peroxide and or sodium silicate or organic stabilizers will be present, and here the pH will be higher. Singeing, it's a dry process, hence there will be no wastewater generation. Mercerizing, surely there will be wastewater, and it is of highly alkaline nature. The pH will be higher, and caustic soda is used, hence NaOH will be present. Dyeing process, there will be metallic compounds. In case metal complex are used as dyes, there will be salts, surfactants, toxins, organic processing assistants, cationic materials. Color will be there, BOD, COD, sulfide, acidity or alkalinity, and the spent solvents will be produced as wastewater. In printing process, the suspended solids, urea, solvents, color, metal, heat, BOD, and foam is produced as wastewater. Finishing is nothing but we are washing and making it into a final form. So there the remaining components will be removed. So we will get furthermore BOD, COD, suspended solid, toxins, and spent solvents will be there in the wastewater. So product fabrication is after finishing, and it's also dry process, so there will be no wastewater generation in product fabrication. So next we will see about treatment. So general outline we will be seeing, since in detail we will be seeing in the following units. So we will be seeing the schematic flow chart you are seeing here. So raw wastewater is fed into an equalizing tank. So it's first fed into an equalizing tank for equalization. So why do we need equalization is that the textile effluent contains various characteristic water in every process. So in every steps we get the wastewater obtained is varying in its characteristics. So we can't predict what kind of characteristics is present. In order to produce a uniform characteristic water, we mix all the steps, water from all the steps of processing in a single tank. We allow it to be standby for some hours, and we mix the water so as to produce an uniform characteristics. Next, as I said earlier, cotton processing wastewater is rich in alkaline content, so we need to neutralize the water to bring it to around the neutral pH. So what we add is we add dilute sulfuric acid along with certain other agents. We tend to neutralize the wastewater which we obtain. Next, the water is passed to a coagulation tank where coagulating agents are used, and sometimes coagulation aided with flocculation is adopted. After this, the wastewater is passed through a settling tank where sedimentation occurs under the influence of gravity. The waste sludge is removed. Next, the water is passed to a trickling filter, high rate trickling filter, and then to a secondary settling tank. So, and for process efficiency, what we do is we recycle the sludge and we do the trickling filtering operation and secondary settling operation again, and then the treated effluent is obtained. So this is a schematic representation of how effluent water from a cotton textile mill is treated. So far we saw the process of processing a cotton and how much water is essential or consumed in each steps, and the characteristic of each effluent water and the treatment method. So in the following video or in the next video, we will be seeing about the characteristics and treatment of the wastewater obtained from wool and synthetic textile processing, and also the reduction of load. And thank you for listening.